So the mean is what most people call the average. You add up all the values and divide by how many values you have. Mathematically, we write it as the mean is equal to the sum of all values divided by n, where n is the number of cases. So for example, for class A, if we add up all the 13 IQ scores and then divide that by 13, we get 110.54. For class B, again, we repeat the same calculation, we get 110.23. So the two classes have almost identical means, about 110. Okay, so this is how we calculate the mean. Now, there's something important about the mean. It's a balance point. Imagine a seesaw. Each person's score is like a weight placed on the seesaw at that person's score value. The mean is exactly where you would place the fulcrum so that the seesaw balances perfectly. All the deviations above the mean exactly balance out all the deviations below the mean. But the mean has a weakness. It can be badly affected by outliers, which are data points with extreme values, unlike the rest. So for example, suppose you're looking at incomes in the United States. If you calculate the mean income and include Bill Gates, for example, the average gets pulled way up, even though most people earn nothing close to what Bill Gates does. The mean becomes misleading because it doesn't represent the typical person experience. This is why when you read about average household income in news report, they typically use median instead of mean. Okay, so because outliers can make the mean really a bad measure for central tendency as soon as you get some outliers. So the median is the middle value when data is listed in order. It's a point that divides the distribution into two equal halves. 50% of cases are above it and 50% are below it. We also call it the 50th percentile. So for class A in our example, when we list the IQ scores in order, the middle value, which is number 7 out of 13, is 109. So you can see that here, the middle point is 109. 6 cases are above it, 6 cases are below it. If the first unit were to drop out of class A, there would be a new median, just because we would only have 12 data points in that case, so we have to take the average of the two middle ones, 19 and 110. So the nice thing about the median, it's completely unaffected by outliers. So if one student in class A had an IQ of 400 instead of 140, the median would still be 109. Doesn't care about the extreme value. Also, in symmetric distribution, where the data is evenly distributed on both sides, the median and mean are identical. But in skewed data, where the distribution is lopsided, they will be different. The mean will be pulled towards the skew, while the median stays in the actual middle. So you can see here, if the data is symmetric, mean and median will be the same value. If the data is skewed right or left, then the mean will be pulled by the outliers on the right tail in this case, but the median will not be impacted. Now the mode is simply the most common value. It's the value that appears most frequently in the dataset. So looking at the combined IQ scores for both classes, the value of 109 appears 3 times. All other values just happen once or twice. So the mode is going to be 109. Now, it's possible to have multiple modes in a dataset. If two values appear equally frequently and more often than any other values, you have what's called the bimodal distribution. So you can even get three modes. It's possible. So this distribution here is bimodal. It has two modes, but you could also get more. The mode is useful because it tells you the most likely experience. If you ask what IQ score is the most common in this group, the answer is the mode. Now the mode has a limitation. It might not be at the center of the distribution at all. Imagine a data set that's heavily skewed. The mode could be way off to one side, while the mean and median are in more central positions. So when do we use each of these measures? For symmetric data, they're all going to be the same, as you can see here. So you can pick whatever you want. For skewed data, the median usually gives the best picture of the typical person. The mode tells you the most likely value, and the mean is useful for further statistical calculation, which is why statisticians often prefer it, even though it's not the best representation of central tendency. Now that we described the center of the data, we need to describe the variability of the data. Okay, so we can have two completely different groups with the same mean, median, and mode, but the distribution of the data between them is totally different. So that's where measures of variations come in, because they tell us about the spread of the data, how different people's values are from each other and from the center. Think of it this way. Imagine two classes, both with mean IQ of 110. What if class A had an IQ ranging from 108 to 112? So almost all the students are about the same range, level of IQ. But class B had a range from 80 to 160. There's a huge variability. They both have the same mean, but they're totally different groups. Measures of variations will help us capture this difference. The first measure is the range. So this is the simplest measure of variation we can use. It's just the highest value minus the lowest value. So for class A, the range is 140 minus 89, which gives us 51. And for class B, the range is going to be 162 minus 80, which is 82. So class B has more variation than class A. But there's a limitation to the range. It only looks at the extreme values, the highest value and lowest value. So if you have one outlier in the data, the range will become inflated and doesn't really represent the typical spread you have in your data. So another measure of variability is interquartile range. So IQR essentially is defined based on quartiles, which are values that divide the data into 4 equal parts, each containing 25% of cases. So the 25th percentile will be the point where the first quarter of cases ends. The 50th percentile is the median, as we said earlier. The 75th percentile is where the 3/4 of cases have fallen below. And then the interquartile range will be the difference between the 75th percentile and the 25th percentile. It shows you where the middle 50% of the data falls, which completely ignores extreme values. So, for example, for our IQ data, the 25th percentile is about 96.5. And the 75th percentile is around 123.5. So the IQR will be 27 point. So this tells us that the middle half of the students have IQs spread across a 27 point range.